let's look at this example. This question is asking for us to determine the lattice energy for magnesium fluoride based on the data that is provided up here, right? So they give us different enthalpy data for different things about the two elements, magnesium and fluorine. And the question is asking for us to calculate the lattice energy based on that data. So what I've done here is that I've written down my own version of the Born-Haber cycle applied to magnesium fluoride. So this is my starting point right here, magnesium and fluorine, right? Now to get from there directly to the product, that's this equation right here, and the enthalpy change for that would be the enthalpy of formation, which is given as minus 1,124 kilojoules per mole. Then I started with the magnesium here and looked at converting the magnesium solid to magnesium gas. That is the enthalpy of sublimation, which according to the question is equal to 146 kilojoules here. And then for the fluorine, it's converted to 2 fluorine atoms per molecule. So that's the bond dissociation energy, which is given as being equal to 159 kilojoules in the case of fluorine. Then I took the magnesium and looked at the energy changes that would take place when the magnesium atom loses the 2 valence electrons, right? So there will be 2 ionization energies that would be involved here, I1 and I2. I1 is 738 kilojoules, I2 will be equal to 1,451 kilojoules. So that would be the total amount of energy, the sum of those two, that would be needed to convert the magnesium atom to the magnesium 2 plus ion. In the case of the fluorine, because they're gaining the electrons, then the fluorine will be undergoing this reaction where the fluorine atoms, gaseous, will be converted to the fluorine gaseous ions, right? So the energy required for each fluorine atom is called the electron affinity, and because you have 2 fluorine atoms, then the amount of energy would be 2 times the electron affinity. According to the question, the electron affinity is equal to minus 328 kilojoules per mole. So therefore, we multiply that by 2 to get the total amount of energy change occurring when the 2 fluorine atoms gain 2 electrons to form 2 fluoride ions. And then we get to the combination of magnesium and the fluoride to form magnesium fluoride. That would be equal to minus the lattice energy, right? So that basically completes the cycle. And therefore, the enthalpy of formation here, which is minus 1,124 kilojoules, would be equal to the sum of all these values that we have over here, plus this, to give us equal to that, right? So that's basically what I've done here. I've equated the minus 124 kilojoules to be equal to the sum of all these here, including minus the delta H lat. And basically all we have to do is solve for the lattice energy. So what I did was that I add up all these numbers right here, and I ended up with this answer, or this result, 1,838 kilojoules. And then what I did was that I basically solved for the lattice energy by adding delta H lat to both sides to get it on this side, and adding 1,124 kilojoules to both sides. And then the final answer I got is 2,962 kilojoules. Okay, so that's basically how this is done, all right? The next video I'm going to post, we're going to talk about Lewis structures for molecules and ions, all right? Until next time.